Serverless is a word used to describe functions that get deployed and run without the developer having to manage the infrastructure explicitly. So with serverless, instead of creating a server and installing the dependencies and executing your code, the developer just provides the code to the serverless API, and the serverless system takes care of the server creation, the installation, and the execution. Serverless was first offered with the AWS Lambda service, but it has since been offered by other cloud providers like Google Cloud Functions and Azure Functions. There have also been numerous open source serverless systems. On Software Engineering Daily, we've done episodes about OpenWhisk, Fission, and Kubeless. All of these use Docker containers and probably the Kubernetes container management system. The Kubernetes container management system is useful for building these tools like a serverless platform or a distributed database. Kubernetes is quite useful for building higher level distributed systems. Chad Arimura is the VP of Serverless at Oracle, where he runs the FN project, which is another open source serverless platform built on Kubernetes. Today we're going to be exploring FN and serverless in more detail. In the past, Chad ran Iron.io, a message broker platform. And Chad is also joined by Matt Stephenson, who is a senior principal engineer at Oracle and who has worked at Amazon and Google. At Google, he worked on the Google App Engine, which was arguably one of the first serverless platforms. It was great talking to Chad and Matt about the different serverless tools built on Kubernetes and the trade-offs that these different serverless tools are exploring. Test Collab is a modern test management solution which integrates with your current issue manager out of the box. For all development teams, it's necessary to keep software quality in check. But testing is complex. There are various features to test, there's various configurations and browsers and platforms. So how do you solve that problem? That's where Test Collab comes in. Test Collab enables collaboration between software testers and developers. It offers wonderful features like one-click bug reporting while the tester is running the tests, collaboration on test cases, test executions, test automation integration, and time tracking. It also lets you do a detailed test planning so that you can configure platforms and browsers and configurations or any variables in your application and divide these tasks effortlessly among your team for quality assurance. All of the manual tests run by your team are recorded and saved for analysis automatically, so you'll see how many test cases passed and failed, with plenty of QA metrics and intelligent reports which will help your application's quality. It's very flexible to use and it fits your development cycle. Check it out on testcollab.com/sedaily. That's testcollab.com/sedaily. Testcollab.com/sedaily. Chad Arimura is the VP of Serverless at Oracle, and Matt Stephenson is a senior principal software engineer at Oracle. Guys, welcome to Software Engineering Daily.
Thanks for having us.
Thank you.
I'm going to start with a little background on both of you. Chad, you built and led Iron.io, which is an event processing system and a message queue. This is a managed service that was not built within a major cloud provider. How do you build a managed service from outside of the major clouds, and what are the difficulties and the benefits of that process?
Yeah, that's a great question, Jeff. So we built Iron.io back in 2010, 2011, back before serverless or any of this stuff was even a thing. And one of the big challenges of that is we're relying on all the cloud providers to provide infrastructure for us. But it's also an opportunity because a big vision that we had was creating an open source multi-cloud platform. And so we had the advantage of having a development layer on top of multiple clouds where our customers could easily run workloads and move them between different clouds. So It was pretty early, but it was a pretty strong vision, and we're proud of what we built there.
What cluster manager did you use at Iron?
This was before all of the big cluster managers that you know of today. So we built everything basically proprietary. But when Docker came on in 2014, we used that to containerize everything. We made that the first class citizen package manager for the workers themselves that customers would ship code. So Docker became a central point to our infrastructure, but we built everything on our own.
And as the container orchestration wars unfolded, I guess, you were bearing witness to that. You probably were faced with the choice of, do we go with Mesos or Docker Swarm and eventually Kubernetes like everybody else? Did you have any experience like that in the container orchestration wars period?
Yeah, I mean, definitely everybody was trying to get our attention, and everyone was saying that they were going to be the future of the operating system for the cloud. And honestly, they're great technologies, all of them. But we took a step back when we launched Iron Functions. We said we're going to be completely orchestration agnostic, and we're going to build it in a way such that it handles its own scheduling. But you can utilize any of the orchestrators to provision and help with the orchestration behind the scenes and help provision infrastructure. But outside of that, we kept it all above the orchestration layer so that we handle that all.
This is one thing that took me a while to understand, is that there is scheduling, and then there's also orchestration, and there's also just the API that you're given. So when I was trying to compare these different container orchestrators during the container orchestration wars, when people were really trying to make a decision for which of these, Kubernetes or Mesos or Docker Swarm or whatever else, there were a bunch of other ones, which one to use, there was a lot of different axes to compare them on. But I think the reason that Kubernetes took all of them by storm was probably a combination of network effects and the limited API, sort of constrained, and there was a clear bounded context to what Kubernetes was trying to do. From your perspective, what led to Kubernetes taking more mind share from the other container orchestrators?
Yeah, honestly, a big part of it is perception and the fact that, and Matt will have a great perspective on this having been at Google before, but my take on it is that a big part of it is that when Google says they use something to handle its millions of containers per day, or maybe even billions per day, the community listen. And that's a pretty big stamp of approval to put behind a specific technology. And if you give it the airplay and you give it the developer relations and you built a good code base, with Google's stamp of approval behind it, the perception is that this thing is more battle tested than the others. It's got a really solid foundation to be backed from, and we're going to put our trust in it. And that was a big part of it. Obviously, there's a whole, like you said, a whole bunch of axes there, but I think that was a big part of it.
Yeah, I would tend to agree as well. The thing that I think makes Kubernetes stand out against other Google projects that were similar leading up to it is perhaps that it has a much nicer and cleaner user interface. The primitive constructs are a lot more straightforward. Contrast it with Ganeti, which was like a virtual machine management open source project from Google as well. And I think that the actual engagement with community was a lot stronger with Kubernetes. And they reached out to other organizations to try and leverage the skills and experience of people outside of Google, which I think is really critical for successful open source projects that Google has shipped over the years.
Matt, you've worked not only at Google, but also at Amazon. When you were at Amazon, you built a scheduler and a build system. Tell me what you have learned about building internal clouds from your time at Amazon and Google.
Well, I guess at Amazon, I was early in my career, I kind of learned the lesson that build and deployment and scheduling and runtime, it's all the same thing. You start off that whole experience of a developer writing the software and building the actual artifacts that are going to be run later on. It all needs to be integrated together. So I think that was probably one of the biggest takeaways I got from Amazon. And then at Google, I kind of leveraged that to build a lot of support through tooling of App Engine. So yeah, anything specific?
Well, I guess the two of you have a bonding fact over the experience of having to build your own orchestrator or fully integrated orchestration and scheduling system from scratch. Have you shared any war stories with each other?
Yeah.
We all have our scars.
I think recently in a chat channel, someone called me the Cullen McLeod of cloud because of all of the stories that I've been able to rattle off the cuff. So,
yeah, and from my perspective, I think we're fresh out of KubeCon Europe and already starting to focus on the efforts going into KubeCon US in Seattle in December. And it's clear that Kubernetes has become a big winner in this space, and there's a lot of effort going into it. There are, I think, a lot of raw spots too, and it's still really early for, I think we're still, to use the Gartner hype cycle, we're still at the top of the hype cycle, the peak of inflated expectations with both serverless and to some degree Kubernetes. And so the question is, does an enterprise invest in just Kubernetes? Does an enterprise invest in a full integrated cloud solution, or is it a combination of the two? And my battle scars come from having built this stuff. Like, we want to avoid building this stuff as much as possible here, which is why we're putting a ton of investment into Kubernetes, aligning FN with Kubernetes, launching a Kubernetes service on top of Oracle Cloud, running on top of bare metal. And we literally just got out of a conversation yesterday about what are all the different surface areas that we want to intersect FN, Oracle functions, with Kubernetes, and how do we align ourselves really tightly with that community? Because there are so many things that it does really, really well that we've all built in the past so many times. And why should we reinvent the wheel when Kubernetes is going to tackle a lot of these hard challenges? And I think that's where the community is today, but we still have some way to go there.
And Chad, when you were at Iron was itself a serverless service. It was a serverless message brokering system, event processing system. And you saw firsthand that people do not want to run their own message queue. They want a message queue abstraction to interface with, but they don't want to have to think about scalability, for example. And then you take that notion to the logical extreme through the things like database as a service, message queuing as a service, data engineering as a service. When you think about, something like Amazon Redshift or Google BigQuery, but you take it to its logical extreme and you get to the serverless function idea. And clearly people want this serverless at every layer of the stack, from everything along the gradient, from these functions as a service where you have primitive elements of code that are deployed in a serverless fashion, to highly integrated serverless constructs like a serverless message queue like you were building in Iron.io, and serverless database. What other beliefs have you developed around the idea of serverless?
When I'm not sure if you're familiar with Iron Worker, but that was actually our flagship product at Iron. And in 2010, we released something called Simple Worker, which was the concept of zipping up some code, including your dependencies, using our API to send that to us, and then we would run that for you. And we actually called it serverless, which is, I know that Simon Wardley talks about how he built a FAS in 2006, but he actually called it frameworks as a service. And so we're very much aligned with being early in this market. But if you think about what we had built in 2010, fast forward to 2014 when Lambda came out, I mean, that is almost the exact replica of what they built. However, we were primarily asynchronous code batch processing as opposed to more synchronous API development. And when you think about when customers came to us and they said, well, we really are interested in this because our developers don't want to deal with infrastructure. They don't want to deal with orchestration. They don't want to think about that stuff. What can we do with it? And the answer is always, well, you can almost do anything. It is just code. So we leave it up to you to figure out what you want to do with it. And that is both a blessing and a curse, especially for a startup. When you tell someone they can do anything, suddenly you're sort of talking to nobody specifically or no one solution. But at a place like Oracle, where our customers are doing everything under the sun, and we can invest heavily in this over the course of many years as this market develops, really the answer is you can do anything with serverless. And we're starting to see more and more architectures move over. Like you said, all of the different components are moving to serverless. So you're standing up databases and not thinking about the individual VMs that run them. You're standing up queue services. You're standing up notification services. You're standing up email services and text messaging and now functions. And you're never having to think about any of the underlying infrastructure. And it's a very powerful thing for developers once they figure out how to wire these things together.
You're both at Oracle now. You're working on the FN project. What is FN?
Well, FN is, if you're using a Mac and you look at the bottom left corner, there's an FN key that stands for function. That's basically what the FN project is. However, the FN project actually encompasses more than just functions as a service, but at its core, it's a functions as a service platform 100% open source under FN Project GitHub account or org. And anybody can take this and stand it up on any infrastructure and run their own serverless platform akin to like a Lambda, Google Cloud Functions, et cetera. And we're providing a bunch of tooling to make that very easy, and we're operationalizing that at Oracle, as you can imagine. But there are other adjacent projects as well, such as FN Flow, which is more of a workflow type product. Again, 100% open source, but it uses primitives directly from the language primitives themselves. So for example, with Java, we use completable futures from Java 8, and that allows you to build more complex workflows. So it's basically a project that's looking to operationalize and bring serverless to the enterprise, both in the cloud as a service and on-premise as well. That's the spirit and the goal of FN.
We've done shows at this point with Fission, with Kubeless, with OpenWhisk from IBM. These are all different open source serverless platforms. We've also done shows about the Microsoft serverless platform, the Amazon serverless platform. There's a lot of options, obviously, but I think we should, at least for the sake of the first part of the conversation, focus on the class of open source serverless platforms that are built for Kubernetes, which in itself encompasses the FN project, Fission, Kubeless, several other projects. Why are there so many of these things? Why are there so many serverless platforms that are built for Kubernetes?
You know, anytime you strike on something really valuable and really useful and really interesting, there's going to be a lot of, I don't want to call them clones, but there's going to be a lot of options. And then you see a consolidation. And this is the pattern that we've seen over time with every technology that's come to market. As soon as the hype cycle starts to move up, everybody wants to jump in and build something. Everybody's got a slightly different solution or a slightly different take on it or a slightly different vision for how the future goes. And they release something, it becomes popular or slightly popular. And then once this hype cycle starts moving into the trough of disillusionment, you start to see consolidation. And it's no different with functions as a service. We released Iron Functions at Iron, I think back at about 2016. And so we were one of the first platforms on. We've always had the vision of bringing this to market. We decided that Iron wasn't the best platform to do that. But when we met the folks at Oracle, we realized that, hey, here's a major cloud provider, a major infrastructure provider that's growing like crazy. And they are really interested in serverless. And they're also interested in doing this with an open source angle to it. And so that's when we came to the idea, let's bring Iron Functions to market as FN project inside the cloud group here at Oracle, so that we are one of the only major cloud providers to be bringing a fully 100% open source platform to market and then operationalizing that on top of Oracle. And we've got a whole bunch of sort of strategic advantages, but that's really the big one right there.
Flatiron School is an outcomes-focused coding bootcamp that trains people to launch a new career in technology in as little as 15 weeks. Flatiron School trains students across the full stack, from the front end to the back end and everything in between, over 15 rigorous weeks. Students learn to think and build like software engineers, from developing coding skills to gaining an understanding of how products are designed and managed. Flatiron School has both online and offline courses, and if you want to get started with an online course, you can go to flatironschool.com/sedaily and get $500 off your first month of Flatiron's online web developer program to get started with a career in software engineering. If you like that online course, you might enjoy checking out Flatiron School's in-person courses that are the 15-week immersive courses. On their website, Flatiron School has a jobs report that details the outcomes of students who have gone through Flatiron School, and they report a very high percentage of graduates getting a job offer and accepting a job offer after their curriculum at Flatiron School. So check it out at flatironschool.com/sedaily, and if you want to get started with the online web developer program, you can get $500 off your first month and get a jump start in software engineering. Thanks to Flatiron School for being a sponsor of Software Engineering Daily. The idea that we're going to eventually have some convergence around the vertical of serverless platforms that are built on Kubernetes, there's some debate around this matter. Like, obviously, we had convergence around Kubernetes, and we reached a point where every major cloud provider is building a managed Kubernetes service. You could imagine a world where eventually every cloud platform offers some API into the function management and deployment side of things, and maybe it'll just be an API that's, defined as, within the community somehow, or maybe it'll actually be an implementation like the FN project or OpenWhisk or whatever else. But, it seems like there's a race to be able to disintermediate the AWS Lambda side of things. Because what people are sort of afraid of is that AWS Lambda could potentially be a mode of lock-in for people, a very low-level mode of lock-in on AWS. I guess one thing I'm having trouble understanding is how compliant are these other serverless platforms, the open source serverless platforms, how compliant are they with AWS Lambda? Would I be able to, if I've written all of my glue code on AWS Lambda and I want to port it to an open source solution, how much pain is there in ripping out the tight couplings to the Amazon platform?
I don't think that the functions themselves are really exactly where a lot of the lock-in is going to happen. I mean, we've even got an API endpoint called FNLB that will import Lambda functions directly from AWS into FN, whether you're running FN on AWS itself on top of the primitives, the server primitives, or you're running it on-prem. I don't think that's really the source of the stickiest lock-in. I think that the secret there is that Lambda, what it does, or serverless is what it does, is it ties together all of these different services, and they've got nice integrations. And the experience of serverless is all about the integrations that you have with all the different services and all the different tooling pieces that you're using. And when you look at AWS or Google or Microsoft or any of them, it's a really great experience to integrate these with all the different, like DynamoDB and SQS and S3 and all these different things tie together. But suddenly you've got 10,000 functions, all of which are tied to 20,000 different integration points with all these different services, and the gravity of your data and just the sheer gravity of all of this entanglement, that's the hard part to move off. And so if you're not thinking about your architecture up front, I think that's the biggest opportunity that Kubernetes and the CNCF and the cloud and the serverless working group and cloud events, the big challenges that we're tackling there inside the working group is how can we create an architecture using open source components that you can take this thing and deploy it to any of the primitives on any of the clouds, but not get basically tangled into that mess, but also have the opportunity to take advantage of a lot of the services that the different providers bring to market. And I think that's what we're all trying to figure out.
Yeah, I would add that a lot of, Google, Amazon, they both provide APIs that are very convenient to use for various nitty-gritty operations like searching or GIS type operations and things like that. The nice thing about something like FN is that our primitives are containers, and so there's always open source projects available that can provide a lot of these sources, these same kind of functionalities. So it's pretty easy using what we've built in the open to stay mostly in the open and not necessarily have to tie yourself to these various APIs. Back at App Engine, it was a pretty big thing for one of the biggest use cases we had at App Engine was generating PDF files. Like people would create apps that just you call it and it generates a PDF file. And we provided a service for it for a while and didn't really have that much uptick. People just wanted to still run their own PDF generation.
So this is a lot of the work we're doing with cloud events, where a lot of these things represent events. And if we can standardize on what that message looks like, on what that payload looks like, on what representation of what an event looks like, and standardize that across the industry. And there are literally every major vendor has been contributing to this effort. And if you're not familiar with cloud events, it's an incubation or sandbox project inside the CNCF now that we've been helping steward alongside some of the major vendors. So FN announced a native integration of cloud events back at KubeCon EU. And by the time this podcast airs, we'll have announced some VS Code integrations if you're using Visual Studio Code to do your development. And so if we want to provide an open source experience, but standardized around things like cloud events, to where we can essentially help customers unlock from the entanglement that they have on the different providers. And as Oracle, we obviously want to provide one of the best infrastructure platforms to do that, that's well integrated with all the other Oracle apps and everything that you're using. But ultimately, Kubernetes is a big piece of that platform story of unlocked from the providers.
The cloud events idea, this is important because the way that people stitch serverless functions together with other things in their infrastructure is oftentimes an event-triggered system. So you have an event that your serverless function will trigger on, and the API for that event, if it's specific to one cloud provider, then you would have to build a way for your services to emit events that are compliant with each cloud provider you're using, and it would be much easier if we just had some sort of common language around what an event is. Is that an accurate representation of what the cloud events project is all about?
Yeah, I mean, that's a pretty accurate representation. I think the serverless working group really exists to talk about how, as major vendors, oftentimes major competitors, but how can we harmonize around a set of primitives so that are such that the application experience, the developer experience is unified, and we can begin to unlock these entanglements. And cloud events was the first major piece of this. If you can standardize on what essentially the communication layer looks like for events, what the protocol looks like, what the event format looks like, then what that does is unlock a lot of functionality or a lot of innovation opportunity for even like upstream providers like IoT devices. If they emit cloud events, then you can automatically, all the different services and the different providers can understand how to consume those. And if they're then emitting cloud events, then other downstream services know how to speak cloud events. So there's just so much opportunity there to speak a common language. And we think that will unlock a lot of innovation in a way that's not all cooped up on a single provider, but happens almost across provider. So ultimately, the benefit is for developers and the organizations consuming serverless.
I want to throw something out there. So when I was at KubeCon, I was at KubeCon Europe as well, and I really enjoyed the conference. And one thing I sensed at the conference was that there were a lot of enterprises that were very willing to spend money to invest in their Kubernetes installation. And I think the vendors at the conference were very happy because they were finding customers that wanted to pay for that vended software, and there were enterprises that were happy to pay. It was a very nice marketplace. It was the sense that I got. So I'm wondering, first of all, if you two got the same impression, but also more generally, is the lesson here that even if you are a major cloud provider, perhaps a major cloud provider with as much heft as Amazon, the lesson here is that we would have had this world 2 years ago if we wouldn't have been having the container orchestration wars. I mean, the container orchestration wars were probably important because a lot of ideas got worked out and so on, but my sense is that customers were a little more gun-shy back then because they sensed like there's some friction and there's some churn going on here. And now you really get the sense that everybody is since they're aligned around Kubernetes, the enterprises are happy to make purchases around that. Did you guys conclude the same lessons, or maybe you have some other lessons around the idea of this business marketplace that has developed around Kubernetes?
It's definitely a balance between adopting early so that you can get a strategic advantage and deliver a lot of your business value earlier than your competitors, and being too early versus being too late. Or on the flip side, if you're too early and the market changes, then you're stuck with technical debt that you then have to go and either continue to support or make the decision to rip and replace. And this just happens through every technology cycle. I think my perspective, again, to reuse the Gartner hype cycle, KubeCon EU, for me, really felt like the first real effort to move out of the trough of disillusionment into more of the slope of enlightenment, where now we're starting to see real use cases, real workloads, real vendors. I mean, don't get me wrong, there's still a lot of hype and it's still a bit early, but I think it's certainly safe to say that this technology is going to be around for years to come, and it's something that's going to be supported by a lot of major vendors. I mean, last time I looked, there was probably 48 different vendors that were providing some type of Kubernetes service. Those don't go away tomorrow if a new technology comes out that's slightly better than Kubernetes. So I think that there's definitely an opportunity to invest here. That's the feeling that I got from KubeCon.
Yeah, I would say that I think that the container wars kind of left us with a good understanding of what can be counted on now from different container orchestration provider to a different container orchestration provider, right? And Kubernetes is nice because it gives you some pretty clear constructs of like how things are going to be different, say, running on Google Container Engine versus any other one. So I think that, and you've seen that before in other cycles of like the IaaS wars with OpenStack and all of that, we kind of learn at each stage, developers kind of learn what they can count on when they move their software from one platform to another. And I think that's what I saw at KubeCon, is that that's like now becoming a reality. And so people are more comfortable with locking in a little bit to a provider.
The serverless conversation that we should be having, let's get to that. So the engineering of a serverless on Kubernetes platform, to give people an overview of this category of software, it's sort of like if I want to run my own serverless platform, I could use Kubernetes as the engine that is spinning up containers that I deploy my serverless functions onto. And if people want more of an overview of the idea of serverless or serverless open source platforms, we've done previous episodes, so I'm going to kind of assume that people have a bit more of a sophisticated understanding of this than I might otherwise. But when I talk to the other people, the Fission people and the OpenWhisk people, and well, OpenWhisk is not on Kubernetes, I realize that, or maybe you can put it on Kubernetes, but Fission and Kubeless, I think the big difference between those two, and maybe correct me if I'm wrong, but is their approach to the cold start problem. And that is the cold start problem being you write your code and you deploy it as a serverless function, but that doesn't necessarily mean it's stood up as a container that is running and serving traffic. It's code that's sitting in a database somewhere, and when you have a call to the serverless function, when an event triggers that serverless function to run, you actually have to spin up a container in order to run the code. You have to pull it out of the database, put it onto a container, schedule the container, route the traffic to it. And so you have that cold start problem where the first time you're responding to that function call, you have to spin up the actual container and then route the traffic to it. And different platforms have different approaches to that cold start problem. Like maybe you do have one container that's constantly warm that can respond to this traffic. Maybe you could tell me what your vision is for the correct approach to the cold start problem.
Well, it's definitely, you definitely identified one of the major areas of serverless that everybody has to deal with, whether it's the open source projects all the way through to the major providers that have services today. Cold start is just the nature of the ballgame, because when you don't run these things consistently and you only pay for the milliseconds that your functions run, well, you got to fire them up, and you have to ensure that you're not always running over capacity and paying for that capacity as a provider or as an open source project. So you sort of hit the nail on the head of what some of the major challenge areas are, and everybody has a different take on it. The industry is getting better and better, and I think the algorithms to be able to predict workloads is getting better. I think that it's really just going to come down to operationalizing these things, putting them into production, understanding what the workload dynamics look like, even to specific customers and specific workloads that they're running, and understanding, hey, this customer spins up this workload every day at this time. I can use machine learning to be able to better tell when that customer is going to spin up these workloads and bring them up at that particular time. Or I've seen this pattern before with this customer. I can predict with a high level of confidence that this pattern is going to apply also to this customer. And I think we're not there yet. And I don't even think some of the major providers are there yet. But with the amount of data that we'll be able to get running this thing on top of our cloud, we'll be able to start to make a lot of those decisions and get the data to be able to fill a lot of those machine learning algorithms to be able to do that. And as an open source project, we'll be able to pass a lot of those learnings downstream to the open source, or I guess upstream to open source, so that our community can get advantage of that as well.
Yeah, I think that this actually hit the nail on the head for like even before I was here at Oracle, at Google, on App Engine. It was just like the biggest problem that I ever had to deal with was how to get the Java runtime to run faster. There's a lot that's happened. There's a lot that still is happening in the overall community, the software community, for trying to minimize start time of various runtimes, especially in Java. Like we've released the Graal VM, and that's really cutting down on startup time. And the thing that I learned, dealing with this in my past, and that has kind of shaped some of the decisions we've made on FN and some of the decisions I made on open source projects outside of necessarily my work at Oracle is that really like the limiting factor when you have an environment like any cloud environment like this is that you're mostly constrained by I/O in most cases. And so things like very large containers are going to take a long time to start. That's just the reality you're going to have to live with. You're never going to get away from that. So there's certain things that you can do to, say, minimize how much you're having to read in order to get your application started up. And I think that's really like an overall software architecture principle that, we've taken to heart on our team to minimize the amount of like time it takes for any individual piece that we're putting between your software and the outside world, and make sure that time to start is absolutely as small as possible.
Mm-hmm. Yeah, and you brought up a great point, Matt, that the JVM can tend to be fairly large, and the applications deployed to JVM can be quite large. And so oftentimes a cold start is not spinning up a Docker container that takes, 300 milliseconds to spin up, plus a few seconds to load the code. I mean, it could be a minute, 2 minutes, 3 minutes to load some of these things up. And so this is a really big opportunity for us specifically here, because we're literally sitting sometimes feet away from some of the major language architects in the Java org. And so it's a big opportunity for us to tackle this problem so that as the Java community moves into the slope of enlightenment, we can continue to use that institutional knowledge to reduce these times using things like Graal and other tricks to be able to minimize the cold start time so that serverless can really be a powerful use case for lots of enterprises to utilize.
Today's podcast is sponsored by Datadog, a cloud-scale monitoring platform for infrastructure and applications. In Datadog's new container orchestration report, Kubernetes holds a 41% share of Docker environments, a number that's rising fast. As more companies adopt containers and turn to Kubernetes to manage those containers, they need a comprehensive monitoring platform that's built for dynamic, modern infrastructure. Datadog integrates seamlessly with more than 200 technologies, including Kubernetes and Docker, so that you can monitor your entire container infrastructure in one place. And with Datadog's new live container view, you can see every container's health, resource consumption, and running processes in real time. See for yourself by starting a free trial and get a free Datadog t-shirt at softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. When you're trying to solve that cold start scheduling problem, is it a promising approach to keep some containers with the Node.js environment on it, for example? Like you've already got a container with Node.js, so therefore, if somebody schedules a Node.js serverless function, you've already got that container ready, and so you can cut down the cold start problem a little bit. Is that a useful approach, or does it significantly cut down on the cold start time?
Yeah, I would say so. Like, if you think about how Docker works, right, which is usually the container engine you're using under Kubernetes, if you're using, say, the same base image and just applying a little tiny layer on top of that to put your code in there, you're going to definitely reduce the amount of time it takes to pull that image across whatever network you were pulling your image from, right? So if you've got like 80 different functions, they all are various different node functions, then optimizing your base image, making that pretty small, but as long as you're using a very similar one, then you can reuse that underlying layers across your entire fleet of machines that are running Docker, then I think you're going to really speed up cold start.
Mm-hmm. Yeah, and we take it a step further too. Rather than just keeping an environment around, the FN load balancer, we call it the FNLB, actually has memory and knowledge of where all the different customer containers are running on which VMs. It essentially keeps a map around of knowing where to send the traffic such that the containers are still running for customers. And so we can actually continue to send traffic to a single pod or a single container that's running for a customer, and that will just basically respond in real time as opposed to having to load any container up at all. Because even Docker can take 200-300 milliseconds just to spin up. And so if you have a synchronous function, that's too much because the user is left waiting for something. So there's a lot of interesting and hard challenges that are opportunities for us here to solve in that area.
Right. So the FN load balancer you mentioned, this makes traffic get routed to hot instances. Explain in more detail how this FN load balancer works.
Well, basically, it keeps essentially a map of where all of the customer functions are running, and it can essentially know where to place the workloads that are coming in. And so a first request comes in, it does a quick scan, it knows that it's customer A, function 1, and it can send it to specific nodes that are running function A1. But the nodes will actually produce back pressure if they're too busy. And so it will let the router know that it needs to start to spin up more functions on other nodes, and it can then start routing traffic there. So it handles a lot of the intelligence. So that's something that we've been working pretty hard on, and that's another piece of the project, which is called the FNLB.
Something about one of your earlier points is that what used to happen to speed up cold start for like JVM-based PaaS, I think, definitely App Engine did this, but some of the open source stuff did it too, was they used things like Nailgun to spin up the actual JVM itself and then apply a WAR file later on. I think that was we did that with Apollo at Amazon a little bit. We tried getting that to work. So to restart the JVM between app redeployments. That's some neat stuff that you can do for optimization.
Indeed. So when we're talking about the basic deployment process of you get your function written, you deploy it to your serverless platform, whether it's running on your Kubernetes cluster or some managed Kubernetes cluster at a major cloud provider, what happens to that code? Does it just get put into a database, or does it get stored in a container running somewhere? What do you typically want to do upon the deployment of a serverless function?
Yeah, there's a little bit of magic to FN deploy, but none of the magic is behind a curtain that you can't see. It's pretty straightforward. So what you'll notice with FN is it has a set of commands: FN test, FN run, FN deploy. And one commonality across all those commands is that's doing a Docker build. And it's either doing a Docker build with the Docker file that you provide if you want to bring your own Docker file or Docker image, or it will use a pre-built gold container or a gold image. If you do FN build or FN run, it will use, let's say, Go or Java or Node or whatever language that you want. It will build the container, and then it will send it to a container registry. You could be running local, you could be running on Docker Hub, you could be running on some private registry. And then it will do, behind the scenes, an FN routes update, or FN update routes. I think we changed the order of those verb noun. And then it will update the route to tell it, hey, FN API, you have a new image and it's been tagged with a new version. Next time you execute, pull over that new version and execute that code. But the commonality is that everything is built around a Docker process. So this opens up the possibilities, the Docker ecosystem. You can do Docker container scanning. You can use CI/CD framework solutions that all encompass Docker and make that a first-class citizen. It's a pretty powerful model.
You guys are working on this at Oracle. Why is this project valuable to Oracle?
I think for a lot of reasons, but Oracle has made a really big bet in cloud. So if you've seen a lot of the announcements coming out, we have something called Oracle Cloud Infrastructure, and it specializes in bare metal nodes and GPUs, and it's one of the fastest cloud. It's one of the least expensive cloud. It has enterprise SLAs, and a lot of it is made of compute, storage, and networking. And so, as you can imagine, we're building a whole lot of other services that developers are asking for. And serverless is obviously a really major component to the future architecture of software. And so I think they recognized this early. We started talking to them. And the reason that we did it open source is because it's a differentiator for customers to be a major cloud provider that's taking an open source approach to serverless. And Oracle is really interested in this vision because I think that a lot of the customers we're going after are both enterprises and developers that really like to see an open source alternative. And Oracle believes in that vision. And that's where we found ourselves.
Yeah, kind of to speak to both of your prior two questions, and I think that the fact that there is no special magic for where we put your software is kind of the neat thing about how we've built this. There's nothing magic there. You can go look at the code in the open source project and you'll know your code's going in a very specific location. It's just going into a Docker registry. So it's not like, other platforms that I've worked on in the past where we have these massive internal projects that you don't really know about as a customer. No one really knew about Spanner back in the day at Google. So, that's a big differentiator, I think.
Yeah, and it's interesting being here at Oracle because we're releasing a lot of the services that some of the other providers have, but we have the luxury of being able to see what was done right and what was done wrong. And so I think there are some really key areas that we're going to innovate and outlead the market. And then there are other areas that we don't need to be innovators, but we can have the advantage of knowing what worked and what didn't for some of the other providers in those areas. And all of that value then gets passed to both our existing customer base and our future customer base as well. So expect a lot of cool things happening.
Are there any examples of services you can think of where there are learnings that have come out of previous cloud provider experiments where you feel like maybe the benefit of not being the first mover can manifest?
One of the key areas is how the integration experience looks like with the various services. When you think about some of the other providers, they had a bunch of services and then their function service came out and then they're like, uh-oh, how do we get this thing integrated? And then suddenly you look like a service that bolted on and super glued a bunch of pieces together. And the user experience, there's some areas that are left lacking there. And so it sort of looks like you're using 40 services to build an application. Whereas I think one approach we're taking at Oracle is it's going to be a much more beautiful experience for application developers. And it's going to be built more on open source components around Kubernetes and the CNCF projects, where it's more of an integrated approach and it feels like a platform as opposed to a bunch of rubber band superglued services. So that's one thing that we're focusing really hard on.
Yeah, I would say I definitely pull a lot from working on App Engine when it comes to decisions around tooling and such. I mean, when I got on that team at Google, one of the things that I noticed was that we still were recommending people build their WAR files using Ant when Maven had been definitely the leader in build tools for Java for years at that point. So yeah, we're trying to build everything so that existing tools that people are using in the industry work, we're not going to build something we're kind of disconnected from our community.
App Engine is a pretty interesting historical example because it was, it depends what you classify as serverless or, how liberal you want to use that term. But I think many people would say it was the first serverless deployment platform. And yet, it did get widely used. I think Snapchat even uses App Engine, but I think Heroku maybe took a little bit of its thunder. Heroku seemed to have done something a little bit different. Maybe it was a focus on the dashboard or something to do with the APIs. But I don't know, do you have any other added perspective from that time of working on App Engine, which was arguably the first serverless platform?
Yeah, I think that there were some really big customers. Of course, yeah, Snapchat was I'm out of my NDA timeframe. So yeah, Snapchat was definitely the biggest one that we had, as far as I know. One of the neat things about working on that at Google was that we had a lot of internal projects and pet projects of side companies that would run on us, because it was a lot cheaper to try and provision infrastructure through us than it was to try and figure out how to get it all the way through into provision, get some priority in Borg. But one of the neat things that also people brought to App Engine a lot was various gaming platforms. And so a lot of the times you would play there are a whole lot of video games out there that the underlying actual runtime of the game was running inside of App Engine. You never noticed it because you were inside of an app or something like that on your phone, but tons of that was actually running on top of App Engine. And one of the things that I guess I learned there was that, people really wanted to heavy workloads and they wanted to build this stuff and run it without having to do any kind of infrastructure management, because there were companies that didn't traditionally have a big infrastructure group, or were founded in, places parts of the world where they're not in Silicon Valley. You can't go just find a DevOps engineer off the street and pull them in. And so I think that has led me to a lot of decisions here on FN that are mostly around how do we make it so that we can make an incredibly flexible compute platform that's really easy for people to use. They don't have to work too hard to use it. And, they can bring big, heavy workloads to us and we'll do it.
Yeah, it's interesting you use that example. That was actually, App Engine was a big inspiration for Iron.io. It's one of the reasons that we started the company, because App Engine was pretty early and they had this integrated approach to these different services. For example, the queues were integrated with the database, were integrated with and there were certain constraints that you had to follow. But if you followed those constraints, you had this infinitely scalable application. And we looked at that, Travis and my co-founder and I looked at that and said, this is amazing. This is where the world is going. I can trust Google to run these things and I never have to worry about infrastructure again. And then we realized that there were some constraints there that kept us from doing some of the things we wanted to do. And I think a lot of other customers ran into those similar constraints. So that's when we developed Simple Worker, which was more of a zip up your code, send it to us, and we'll run it, and then we'll figure out a way to integrate it with some of the other services. And then obviously you mentioned Heroku came storming on, where they took both the Rails community and the Git community and created Git push Heroku master. And that suddenly changed the ballgame because it took these different waves and amplified them, and everybody fell in love with it. But it is a marathon. It's not a sprint. And none of these technologies can be successful with just sprinting. You really have to stay the course. And that's, I think, where we're just now starting to see some of these serverless architectures now reach the enterprise. And it's happening in the CNCF. It's happening with Kubernetes. It's happening with the cloud vendors. And we're really excited to be a big part of that.
All right, guys. Well, I think that's a good place to wrap up. What should we expect from the FN project over the next year or so?
A lot of innovation, a lot of reliability improvements. Like this thing is operationalizing here. We've got customers using it. We're pushing towards the GA this calendar year. And there's a lot of momentum behind the project. And we're currently engaged with partners and customers. And obviously, we're building a service internally. And so there's really exciting things happening with FN. So I would say we're really looking for community and contributors. We've got developer relations team. We've got a community team. We've got core engineers working on both open source and service. And so you can expect a lot coming from the FN project. If you want to get involved, we've got a Slack room, just slack.fnproject.io. Come talk to us. We're there basically 24/7. So tune in.
Okay, guys. Well, it's been a real pleasure talking to both of you, and I wish you the best of luck with the FN project.
Thank you, Jeff.
Thank you very much, Jeff.
Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands, all while increasing the security, reliability, and availability of critical business workloads with Azure. To learn more about Azure Container Service and other Azure services, as well as receive a free ebook by Brendan Burns, go to aka.ms/sedaily. Brendan Burns is the creator of Kubernetes, and his ebook is about some of the distributed systems design lessons that he has learned building Kubernetes. That ebook is available at aka.ms/sedaily.
Wow.